Hey everyone, I'm Liebenberg from SSW, and today I've got Henk Boelman from Microsoft. He's a cloud advocate focusing on Azure AI. And we just came from a fantastic talk here at NDC Sydney 2019, where Henk talked about classifying products as fake or genuine. So Henk, welcome to NDC. It's great meeting you, and talk was fantastic. So can you tell us a little bit more about how and why you built this image or product classification system?
Absolutely. Thank you for having me. Yeah, so my talk was about how to create a system that can distinguish products between counterfeit and real, because that is a real big problem in this world actually at the moment. And it is costing like lots of money for big companies. So the company I worked previously, before I joined Microsoft, was asked to create this solution. And the solution had to be like really simple. So it had to be like run on a mobile phone, but they didn't even want that you install an app. So it is a responsive website where you take a picture of the product, it runs through our AI engine, and that AI engine checks for several things on the package. Like for instance, if it is a real logo, if icons are good, and a lot of other secret stuff I'm not supposed to tell. We build it in Azure, running Azure Functions. So the Azure Functions orchestrate the whole chain. And we used Custom Vision for the easy do-it-yourself machine learning.
Yes.
And we used Azure Machine Learning Service for the very specialized models. Okay. So we trained those models from scratch. And my talk was about how to use Custom Vision and how to use Azure Machine Learning Service to accomplish that.
Oh, fantastic. So your initial challenges, what were they? What was the hardest part to solve in that sort of whole chain in building this classification system?
Yeah, so with I think almost every AI or machine learning project, the thing is having enough data to do that. What I learned, there is never enough data. You always need more, and the more good data you have, the better your model will become. So also this whole solution. Yeah,
so the type of data you get is either good or bad data, and that will affect your model and how it predicts the outcomes, right?
Yes, exactly. And one thing that is also very important is that those data sets are balanced.
Okay.
So you need the same amount of good images as you have bad images or counterfeit images. And of course, there are a lot of pictures of the good products because you can make them easily yourself. But like for the counterfeit products, that was like a big challenge in this product.
Okay. So in terms of the product, the fake product, how close do they get to be genuine? Like, I mean, at what sort of point do you decide this is fake or this is real?
Yeah, that is also a little bit the secret of the solution, but it are very, 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 very small details on the box, because you see like people that make really obvious fakes, like use Comic Sans, for instance, on the packages. Then you're quite sure that it is a fake. But some of them are really good, and it is actually in the printing, and you can detect it from there.
Oh, fantastic. So I know it's a very complicated system. There's a lot of secrets you can't give away, but I think you've got something else very exciting in store for us.
Yes. So I can show you like a few things, like the technology we use, but then with like a different data set. Okay. And one of my favorite shows on TV is Simpsons.
Oh, yes. Very good.
So I can show you how to build a classifier using Custom Vision with a sample data set I've created from Lego figures.
Yes.
That represent the Simpsons.
So Lego and Simpsons together?
Absolutely.
Oh, cool.
And then you are able to tell if that is Homer or Marge or Bart or Lisa.
Yeah. Okay. So where do we start?
So we go to the website customvision.ai. You see here. You need to set up some things in Azure. There are lots of tutorials online on docs.microsoft.com where you can get started with that. But once you have created and have your Azure account up and running, you can go to the website customvision.ai. Okay. And you can start creating your projects. So you can do everything through a visual interface, but you can also do everything through code.
Through code, fantastic.
Yes.
Yep.
So everything is backed by SDKs, and those SDKs are available in Python, in .NET, and in Java. Fantastic. So you can choose the language you like.
So everyone's covered.
Absolutely, yes. And they're all very well documented.
Okay.
So when you're here in this interface,
Yes.
you can start by creating a new project, and then you get several options. So the first of all, you have to give it a name. So we call it the Simpsons Lego.
Mm-hmm.
You can give it a description so you can recognize it and tell what it is about. And then you have to choose your resource, which you're going to use for training. That is the resource you've created in Azure.
What's that resource called specifically?
It's a custom vision prediction endpoint.
Okay, fantastic.
Yes.
Okay, and I see there you got two choices there between the types. You got classification and object detection. I know what classification is, but can you maybe explain the difference between the two?
Yes, I can, absolutely. So classification means that you have different classes.
Yeah.
In this system, it is translated as tags.
Mm-hmm.
So you have Homer as a class, you have Marge as a class.
Okay.
And when it runs through the classifier, it will tell you, I'm like 60% sure that this is Homer, and I'm like 1% sure that this is Marge. So it will classify all the images and giving scores per class.
Okay.
Object detection works a little bit similar, but somewhat different.
Yeah.
It will also tell you where the object is in the image.
Okay.
So instead of, it will just tell you I'm 40% sure this is Homer. Mm-hmm. So I'm 40% sure that this is Homer. And this is the bounding box where I see Homer in the image.
Okay.
So that is really cool.
Right,
so you can, you've probably seen like face detection systems that can draw like a rectangle on your face and follow it. So this is what you can do. In this case, if you train an object detection classifier for Simpsons, you will be able to track Homer Simpson through a video.
Oh, fantastic. Cool.
So that is really cool.
Yeah.
So we will do a simple classification project because that is like the way to start.
Okay. So Henk, I see here on the screen we've got various domains. Can you maybe just explain a little bit the difference? And some of them are compact. What does that mean?
Yes. So when you start training your classification model, you have to choose a domain. So if you have like general objects like the Simpsons, you can go for a general domain.
Yeah.
Or if you're trying to classify different types of food, you choose a food domain and so on. So if you find a domain with the word compact behind it, that means it is like a smaller type of model, which you're able to export.
Okay.
So you can export these models from Custom Vision to CoreML, to TensorFlow Lite, to Onyx. That is a general run format that will run on multiple machines. And you can export them as a Docker container.
Oh, fantastic.
So you get the whole Docker container running your model as an API for you.
Right.
And you can host it yourself.
Oh, that's really cool. So, but with the other ones, like you can actually consume that model in your Python or .NET application to then give some input and get a predicted result.
Yes.
Right.
Exactly.
Okay. Cool. And then so the ones that aren't compact, those ones are only available to run through the portal. Is that right?
Yes.
Okay.
So if you're done with training your model, you can publish it. And then it will create an endpoint for you in Azure, which you can consume via a REST call.
Okay, so Azure hosts that model for you?
Yes.
Okay, that's cool.
So let's create a general compact. So we want to see which options we have when we export. So when we select the general compact domain, you already have to make a choice how you're going to export it. So it can be exported to these basic platforms like TensorFlow, CoreML, Onyx, or the Docker container.
Right.
But you can also export it so it can run on the Vision AI dev kit.
Okay, cool.
So let's create a project. So now we have a project where we can start uploading images. So we click Add Images, and we go to our data set. So here is my data set of
So these
Lego
are just
figures.
normal JPEG or similar type of images to upload?
Yes. So you see here that it are just regular pictures. But if we have take a closer look on.
Oh, yes.
And then we will see that I used a lot of different backgrounds for them. Used a lot of different lighting conditions.
Okay.
And
so is that to give some variety to the trained model to not take the background into account? So if it's noise, it'll sort of like try and remove it or ignore it.
Yes, so we will train it to look actually at the object.
Okay.
So if we would have like made 100 pictures with a red background, then it would probably starting to classify our background instead of our Simpson figure.
Okay, fair enough.
So we create a tag for this. We say Homer,
Uh-huh.
and we say upload the images. And it will upload these images for us, and we have them here. We will do the same for March. So we will go back to the training images, select all the images for March.
And what is the sort of the size of these images? Is there like a sweet spot for an image that's either too big or too small? Where does the sweet spot sit?
Yeah, so you have to upload images that are from a decent size,
Okay.
but it doesn't use like a 4K image to train on.
So that's a bit too overkill,
yeah,
right?
so you don't have to upload images that are more than 2 MB, 3 MB per
Okay.
image, but make sure that it is really focused on your object.
Okay.
So don't make a picture, if you do this classification project, that has Homer and March in it. So make
Okay,
sure the
right.
object is like a decent percentage of
Okay.
the image.
Okay, that makes sense. Yeah.
Yeah.
To isolate the image, your
Yes.
object in the image.
Yes.
Okay.
So with the other type of project, object detection, you can actually mark where the object is in the
Okay.
image. But for this simple classification project, we just want to have
Main character
the
there.
main character in
Okay.
yes. So now we're done. We have like 51, 52 images.
Okay.
So here also make sure the classes are balanced. So don't upload 50 images of March and 10 of Homer.
Okay.
Then your model will be like not that good.
All right.
And then when you're done with uploading images, you can hit the train button. And you have two choices. You can do quick training or advanced training. And advanced training, you basically say, hey, you can use 12-hour training budget
Wow.
for
yes.
this. So, but then you need like a really, really big project.
Okay, so is that what sort of use cases would you use the advanced training for? I mean, we're trying to train Lego figures.
Yeah.
I don't imagine it's going to take 12 hours for it to recognize Marge or Homer at the moment, but is there another sort of use case that you'd use advanced training or that long?
Yeah, so
Beautiful.
if you do object detection
Yeah.
and you have like 500 images per class and you have
Okay.
like 50 classes,
Yes.
then you do that
Okay.
that type, and it will take several hours for
Okay.
it to finish.
Oh, fantastic.
So you saw this. This is finished within 30 seconds,
Fantastic. Yeah.
and it has created like the perfect model, 100%,
100%.
100%, 100%.
So that's super ideal.
Yes. So actually, we see here our two classes, and
Yeah.
we see the image count.
So this dashboard is going to give you a nice overview of the quality of your model and sort of what the confidence will be when you use this model.
Yes.
Okay.
Exactly. Yes. So when you're done with training, you can publish it. So
Okay.
here we publish it. You give the iteration because every time you train the model,
Yes.
you get a next iteration of the model.
Okay.
So we give it a name. We say latest, and we can publish it to a resource.
Okay.
And this is also the prediction resource you've created earlier when you set up the Custom Vision endpoint in
That's
Azure.
right. Yeah.
So I'll publish it here. I say publish. And now it is available for any application to call.
Fantastic.
But it is secured with an API key.
Okay. Good.
So not everyone can call it. So here, if you click on prediction URL, you get your URL, you get your prediction key, and some information on how to send your image.
Okay. So they're setting the body to a URL of an image that you're trying to predict and
Yes.
get the outcome of that.
Yeah.
Yeah.
So that can either be you send the image from your local hard drive to the service, or you give it a URL, and it will consume the image. It will
Okay.
get the image from the internet for you.
All right. Okay.
So you can also export the iteration. So here you see the different types. So if, for instance, we click on Core ML and say export, it will generate this model for us.
Yes.
But here down, you see also some sample code.
Yeah. Fantastic. So how
So
do
you
you use
already
it? Yeah.
get like a pre-made Swift application that you can deploy to your iPhone and run these models.
Oh, so if ideally you could walk around with your phone and click away
Yes.
on Lego pieces, and they'll tell you exactly which one's which.
Yes, and that will run totally offline.
Fantastic. Yeah.
Yeah, so no connection to the cloud.
And free.
Absolutely free.
Okay.
Yes. Yes.
All right. Cool.
So you can do a quick test
Yeah.
if you want.
So instead of making an API call, we're going to use the platform here.
Yes,
to,
exactly. Yeah. So we can go to here. We could take a picture I made with my iPhone.
Yeah.
And we see that it here is starting to do predictions against the different classes.
Oh, yes.
So it is like 100% sure it sees March here.
Okay. And I think that image, that is from a different folder than your original data set.
Yeah, absolutely. Yeah,
Right.
these are not in the training folder.
Okay, so you're not actually cheating by using something that's already in the data set.
No,
it has
absolutely
to
not. Yeah.
do the work to recognize this and
Yes.
give you the probability there. Well, that's 100% March.
Exactly.
Oh, that's fantastic.
Yeah. So that's pretty cool.
Yeah.
So you can also extract the image from the internet.
Okay,
So if
yes.
you have a publicly available URL, you can just paste it in here. It downloads the image and it runs the classification on this random image from the internet, and it says that it is 100% sure that this is Homer.
Oh, that's very cool. So now we've used the portal.
Yes.
It looks super easy, but yeah, I think there's also a better way that you're going to tell us about now. And it looks very cool. I've seen this.
Yes.
So what is it?
Yeah. So this is really cool if you just want to experiment, but it is not very repeatable and not very versionable. So you want to do it from code.
Yes.
So you can do exactly the same thing from code as we just saw, just using our SDKs. And I'm going to show you how to do that in a Jupyter Notebook.
So this is Visual Studio Code running Jupyter Notebooks,
Yes.
and those are Python scripts.
Yes. So our latest version of the Python extension for Visual Studio Code can open real-time Jupyter Notebooks.
Fantastic.
So you don't have to be bothered with installing and running Jupyter Notebook servers. It will just run for you in Visual Studio Code.
Wow.
So
Cool.
shall we go through the code?
Yeah, fantastic. Let's have a look.
Yes. So it is Python, so you have to install the SDK.
Yes.
And the SDK you find here, it is Azure Cognitive Services Vision Custom Vision.
Okay.
So you start with importing some dependencies. And then what we have to do is create a project. You saw that we did that through the portal, through this interface.
Yes, yes.
So here we can also give it a name, choose a domain, but here you have to use an identifier.
Okay.
So luckily there is like a method that will give you all the available domains
Okay.
with the
So
IDs.
you can choose which one you want to use and put that in your
Yes,
script. Okay.
exactly. So we create a project here, and then we can start adding images. So how I do it is I have a folder with March and with Homer, and I will loop through these folders and take the folder name as the tag.
Okay. Good
And
idea.
then upload and then tag all the images and then upload the images. So you have to upload images in batches. So you don't upload every image. So you make a batch of 64 images and you upload them at once.
Fantastic. Yeah.
So we have around 100 images, so it will upload 2 batches of images. So here we see it's creating the tags, and now it is uploaded exactly the same test set. So we can go back to the portal,
Yes.
and we can actually see what happened. So here we see this is the project we created earlier, and here we see the project it is just created now, and it looks exactly the same.
Okay.
Only now we can repeat it and check our code into like a version management system and do exactly the same.
That's ideal. Yes.
Yes.
That'll make developers very happy.
Yes, and me as a developer, it makes me very happy. So we can also initiate the training from the code. So we will do that, and you see I've created a loop here that actually asks every second, "Are you done yet? Are you done yet?
Okay.
Are you done yet?" So we have to wait a little bit for this training to be done, and it should be done also within like 30 seconds.
Okay. So this is the same training that was run earlier through the portal,
Yes.
but now you're just executing that via code.
Yes.
Yep.
So the training is completed,
Yes.
and now we can also publish it.
Okay.
So we have to have our prediction key. We actually need the resource ID where we are going to put it in.
Okay.
And I've written a blog, and that blog explains how to actually get this whole string for you. So it'll make things easier. You give it the name of the iteration. We call it latest here. You can call it whatever you want, like version 1, version 2. You can have multiple multiple iterations published on the different names.
Yes.
So you can do like A/B testing
That's
on
great.
on your endpoints.
So with all the ML stuff, you can do some actual DevOps, put some DevOps practices in
Yes.
before you actually publish and release it to production, for instance.
Yes.
Okay.
Absolutely.
Oh, that's really cool.
So you see publishing goes very fast. So we have published it. And then we can start testing the model again.
Okay.
So we can do that through the interface, but we can also do it through code. So I have a directory here with a few testing images. So we will loop through those test images and send it to the endpoint. So we go through. So here we see we have the same image. Here we have March.
Yes.
And we see that it is like 0% sure that this is Homer and 97% sure that it's March.
Yeah.
And here we have the other image from March, and it is like 99% sure that this is March.
Oh, well, very good.
So you can very quickly test it. And the same, it works also with sending URLs to this endpoint.
Okay, yes.
So I will run this also, and it will tell us this is Homer. So now you probably want to see what your project is doing and how it is performing. So you can go to predictions, and here you can see all the images that are sent to your API endpoint.
Okay.
The important thing to notice is that you can put that off. So in the API call, you can specify that it is not going to save the image. So
right.
if you have like sensitive data you don't want to have stored, we just want to run a prediction, it is possible.
Oh, that's a great
But
idea.
for debug purposes, you can have the images here.
So for developers, do they need to be aware of something like the cost of keeping their training data, or is there anything else other than your normal subscription fees that you have to be aware of?
I honestly don't know.
Okay, we'll miss that bit then.
Yeah, they change it every time.
Oh, okay.
So I honestly don't know. I know that you have some free training rounds, but
Okay.
let's
Forget
keep
about
this
that bit.
pricing out. Maybe,
We'll keep pricing out of it. Okay.
yeah,
No worries.
because it probably changes the next month.
Okay.
Yeah.
Oh,
So what you can do is you can click on these images
yeah.
and just see what it has predicted.
So you can potentially see if an image has been misclassified somehow.
Yes.
And can you then remove that from your data set or retrain the data set
Yeah.
with
So
a
you
new
can,
image?
yeah. So you can actually add them to your data set. You can tag it and retag it and say this is Homer, and save it and add it to your data set. So in your next training round, this image is also taken.
Oh, that's fantastic.
Yeah. So now it moved from the predictions back to the training set, and if we hit train in the next iteration, it has used this image to train.
That's fantastic. Well, thank you very much, Henk. That's a very cool presentation. I love this stuff. I think I'll definitely go away from this conference and start playing with Azure Vision Services and ML. It's very cool. Thank you for watching, everyone, and we'll see you again soon.